Okay, we are going to take a look at what we mean by arithmetic sequences. Now, as you probably already know, there are a couple of different types of sequences: series, arithmetic, geometric, and it can be maybe a bit confusing to decide or to differentiate which is which. So, first of all, we look at the word arithmetic. Now, the word arithmetic means to add or to take away. So when we're talking about an arithmetic sequence, we're talking about a sequence where each term either has a number added to it or has a number minus from it. So, for example, nice simple sequence, 3, 5, 7, 9, 11. This is arithmetic because each time we are adding 2 to our number. The reason this is a sequence and not a series is because it is just a list of numbers. With a series that we'll see later, we are actually adding all of the numbers in this list. But the sequence on its own is just a list of numbers. So, how can we come up with a general form, a general equation to find a number in this list? Well, let's have a think about the kind of information we're going to need. So, if I wanted to find out what the fourth term of my series is, my sequence is rather, well, we know that's 9. But if we didn't have that information, if this was something maybe a bit more complicated, then how are we going to generally find that out? Well, I'm obviously going to want to know what I'm adding to each term, because that's a very important piece of information here. And I'm also going to want to know where I start. What is my starting number? And these are the two key pieces of information that we need. The starting number, that we will call A, and whatever we are adding or taking away, that we will call D. And it's these numbers here that are going to be key to working out whatever our 4th or 6th or 107th number are. So, let's think about this logically. How, without any information, would I know that 9 is the 4th number? Well, let's say then my n is 4. I'm looking for the 4th term in this sequence. So I know that to get to the 4th term, I'm going to need to take the first term, A, and I'm going to need to start adding something to it. Well, just from this example, I know that I'm adding plus 2 every time. I'm adding 2 each time. And how many times am I adding 2 here? Well, once, twice, 3 times. So I can say, okay, in this case particularly, I'm adding 3 lots of my difference. Okay, that's all well and good, and that gets me my 9. A, which is 3, plus 3 times D, which is 2. 3 plus 6 is 9. Okay, great. But how do we get a general form for this? Well, we've already got my A and my D. So where can I get this idea of this 3 from? Why is it 3? Well, if I wanted to find 11, which is the 5th term, it would be 4D, right? 1, 2, 3, 4. Add 2 4 times. If it was my 6th term, I'd need to add 2 5 times, and so on. The amount of times that I'm adding D is equal to whatever value I'm looking at, so n minus 1. When n is 4, I'm adding D 3 times. When n is 5, I'm adding it 4 times. So my completed formula is A plus n minus 1 D. And this n minus 1 is key, okay? It's very easy to forget that we need to include n minus 1 and not just n. In this case, it's quite simple, but as we kind of progress, we can see how important it is that we don't forget it is n minus 1. We are never acting n times on a sequence. Okay, let's take a look at a nice and basic example. I'm given that the A in this sequence is 5. So my first value in the sequence is 5. I'm then told I'm adding 7 for each term. So my first term is 5, my second term would be 12, my third term would be 19, and so on. I'm adding 7 every time. So if I'm asked to find the 8th term, nice and simple, pop it into my equation before, a equals n minus 1 d, a is 5, n is 8, d is 7, don't know why I've got an equals there, it should obviously be a plus. 5 plus 7 times 7 is 54. So my 8th term in the sequence is 54. Nice and simple. Okay, let's finish off by looking at a harder example where we are given our A and our D, but it's using algebra. So an arithmetic sequence has first term k squared. As soon as I read that, immediately I'm writing down that A equals k squared. And common difference k. Similarly, as soon as I see that, I'm writing down D equals k. As soon as you see a piece of information in the question that you know is going to be useful, write it down in the form you are used to. A is k squared, D is k. U5 equals 41. So U5 means the 5th term is 41. Or n equals 5. And we are told to find k. Well, let's come up with a formula for the 5th term, for un. Well, we know that that formula is going to be a plus n minus 1 d. I can put in the details that I know. So my un is 41. My a is k squared. My n is 5. So 5 minus 1 gives me 4. And my d is k. And now I'm left with a quadratic expression. I'll rearrange it just to get me a simple quadratic by minusing 41 from both sides. And now I've got k squared plus 4k minus 41. Now on inspection, it doesn't look like we can factorize this. So we'll need to pop it into our calculators and find our values of k. And once we've done that, we get the fact that k must equal minus 2 plus or minus 3 root 5. Now, this is obviously giving us two options, minus 2 plus 3 root 5 and minus 2 minus 3 root 5. So, what's the correct answer? Is it both or is it just one of them? Well, it's just going to be one of them. Because we know that k must be positive. Because k must be positive, it's going to end up being that the only acceptable answer is minus 2 plus 3 root 5. Minus 2 minus 3 root 5 will, of course, give us a negative. So because we cannot have a negative value of k, we must be left with one solution.